Hello everyone, I'm KK. Welcome to Giraffe Tech. Let's see what's interesting today. A few days ago, Long March 10B was still a question. It was a program people compared with Falcon 9, mostly on paper. Now it is evidence. On July 10th, China moved the story from a future claim to a flight result. The first Long March 10B lifted off from the Hainan Commercial Space Launch Site at 12:15 Beijing time. The rocket did the basic job first. It sent its satellite payload into the planned orbit. That matters, because recovery is only impressive if the launch mission also works. Then came the part that changes the whole script. After stage separation, the first stage returned vertically and was recovered at sea. Chinese state media says the recovery used a sea platform and a net capture system. In other words, this was not a Falcon 9 style leg landing. That is why this was not just another Long March launch. It was a recovery demonstration attached to an orbital mission. Xinhua described it as China's first successful controlled recovery of a carrier rocket first stage. China News Service called it a historical breakthrough in reusable launch technology. The real question every reusable rocket program faces is simple. Can you get the expensive hardware back in a condition that matters? Long March 10B has now answered the first part of that question. It has shown that the first stage can come back under control and be captured at sea. This does not make it equal to Falcon 9 overnight. Falcon 9 is not just a rocket. It is an operating system with years of reflight behind it. SpaceX still leads in routine reuse, launch cadence, booster turnaround, customer confidence, and the industrial habit of flying recovered hardware again. But the comparison has changed. Before this launch, Long March 10B was mostly a planned answer to Falcon 9. After this launch, it is a demonstrated recovery architecture. That makes the Chinese answer much harder to dismiss. The old framing was, can China build something like a Falcon 9 class reusable rocket? The new framing is, how far can China take its own recovery architecture after the first success? This is why the story should not be told as a Long March 5B replacement story. Long March 5B belongs to the older one-way heavy lift logic. Long March 10B is aimed at a different problem: regular access to low Earth orbit, lower cost per mission, and hardware that is not thrown away after every launch. In reusable rockets, the word launch is not enough. The important chain is launch, recover, inspect, refurbish, reflight, and repeat. China has now demonstrated the first two pieces of that chain on a major official rocket, launch and recovery. The next pieces are the harder economic test: inspection, refurbishment, reflight, and cadence. Falcon 9 uses powered vertical landing. The booster re-enters, controls its attitude, restarts engines, deploys landing legs, and touches down on a drone ship or landing zone. That process looks ordinary now only because SpaceX made it ordinary. Behind the landing video is guidance, propulsion, structure, software, recovery, logistics, and years of operational learning. Long March 10B is taking a different route. Its July 10th mission used sea-based net capture rather than leg touchdown. This difference matters. It is not decoration, and it is not a minor engineering detail. If the first stage does not need landing legs, China may reduce some structural mass and some precision touchdown burden. But the final burden does not disappear. It moves into the maritime recovery system. The first stage still has to reach the capture zone with the right attitude, velocity, trajectory, timing, and remaining control authority. The recovery vessel or platform has to be positioned correctly. Sea state, wind, platform motion, and capture geometry all become part of the engineering problem. The net system then has to absorb a large returning stage without destroying the engines, tanks, avionics, and structure that make reuse valuable. That is why the July 10th recovery is a strong signal. It was not only a guided descent into the ocean, it was a controlled return into a sea platform capture system. That is a more specific and more valuable result. Chinese reporting says the mission verified several first-stage reuse technologies, including high-precision guidance and control. It also mentions engine multiple starts and high-altitude ignition, propellant management, adaptation to complex force and thermal environments, and sea platform net capture. Those details matter because reusable rockets fail in the interfaces between systems. Recovery is not one technology. It is many technologies working at the same time. This is what makes the Chinese answer more serious today than it was yesterday. The program is no longer only arguing through diagrams and expected specifications. It has now produced a flight result that can be inspected, measured, and used for the next iteration. The hardware class also matters. Chinese reporting describes Long March 10B as a 5-meter diameter, 2-stage large liquid rocket. The first flight vehicle was reported at about 63 meters long, with about 760 tons of liftoff mass and roughly 890 tons of liftoff thrust. The first stage uses liquid oxygen and kerosene, while the second stage uses liquid oxygen and methane, according to China News Service. In reusable mode, the reported low Earth orbit capacity is around 16 tons. That number does not settle the Falcon 9 comparison, but it puts Long March 10B in the right strategic lane. Payload is only the opening data point. A reusable rocket is judged by the whole operating loop. The serious test is whether it can fly often, recover reliably, avoid heavy refurbishment, and return to the launch floor at predictable cost. A rocket with a slightly lower payload can be more competitive if it turns around quickly. A rocket with strong payload performance can still be expensive if each recovery creates heavy repair work. That is why the 16-ton reusable mode figure should be treated as a beginning, not a conclusion. Still, it is a meaningful beginning. It is relevant for low Earth orbit satellite internet constellations. It is relevant for large commercial satellites. It is also relevant for China's future launch infrastructure, orbital logistics, and lunar program support chain. This is where China's answer becomes hard. It is not only building a rocket, it is building a route toward more regular access to orbit. China is not copying SpaceX's company structure. It does not have Starlink inside the same private company in the same way SpaceX does. SpaceX has a vertically integrated launch business, a huge internal customer, rapid iteration culture, and years of controlled failure behind its current success. China's official system is different. It is shaped by state programs, national engineering institutions, launch site planning, satellite internet needs, and long-term mission pipelines. That can make some decisions slower, but it can also provide stable demand, stable funding, and a coordinated national customer base. In other words, China's path may be less like Silicon Valley iteration and more like state-backed infrastructure building. That makes the July 10th mission more important. It shows that the official system is not only studying reusable rockets as a concept, it is now putting a different recovery method into flight and getting hardware back from an orbital class mission. The most important follow-up line may be the reflight plan. China News Service reported that the development team expects to complete a first-stage reuse flight before the end of this year. If that happens, the story changes again. Recovery becomes a step toward reuse, not just a successful stunt. Viewers should separate 3 words that often get mixed together: recoverable, reusable, and economical. Recoverable means the stage can come back. Long March 10B has now shown that at least once. Reusable means the stage can be inspected, refurbished, and flown again. That remains the next gate. Economical means the whole process saves enough money and time to change the launch business. That is the level Falcon 9 has already reached. Falcon 9 has crossed all 3 thresholds repeatedly. It has made reuse part of normal launch operations. Long March 10B has crossed the first threshold in a serious way. It has shown launch, orbit insertion, controlled return, and sea-based recovery. Now it has to prove hardware condition, refurbishment burden, reflight timing, and eventually launch cadence. That is the fair comparison with Falcon 9. Not shape, not slogan, and not one dramatic recovery video, but the operating rhythm after recovery. The July 10th result is still powerful because it moves China from intention to demonstration. It proves that China's official launch system can attempt a different recovery architecture and make it work on a real flight. It also gives China something SpaceX once needed badly: recovered hardware, flight data, and a concrete next step. So the right conclusion is not that China has already matched Falcon 9. That would be too early. The right conclusion is stronger and more precise. China has moved the Falcon 9 comparison from theory to hardware. Long March 10B is no longer just a planned Chinese answer to reusable launch. It is the first successful official demonstration that China can recover a large orbital class first stage through a different architecture. If the recovered stage flies again, the story becomes much bigger. Then China is no longer only catching a rocket at sea. It is starting to build reusable launch as infrastructure, and that is the hardest answer it can give to Falcon 9.
That's it for today. If this was useful, follow Giraffe Tech, MKK. More thoughts on X and Substack. See you next time.